Welcome to the video solutions for day 6 of Barvember. So this is Monday of week 2. It's also Maths Week England this week. Now, I've said throughout last week, and I'll say it again about question 1, the best questions for learning the basics of producing the models are ones that you already know how to do. So don't worry if this is a question you know how to do. The challenge is, can you create the pictorial model properly? So we're just going to go through a reminder of our bar model elements. So we use a bar to represent a number, and if we know the value of that number, we write it in the bar. Let's try and label our models carefully. So we're going to have 2 bars here, one for boys, one for girls. We know the number of each of those, that there are 19 boys and there are 12 girls. And we've made sure that the girls bar is smaller than the boys because 12 is smaller than 19. And we're asked how many more boys than girls are there in class 2. And this is a really important element in our pictures, is this double-headed arrow which represents the difference between 2 bars, and difference should suggest to us that we're going to do some subtraction. And we've seen lots of different ways of this bar appearing. We've talked about more, as it is in this example, less, fewer, younger, older, bigger, smaller. We've got lots of words that might lead us to this idea that we're looking at the difference between 2 bars. And our most important element is our question mark, because that's telling us what it is we're aiming to find out. So there we have it. We don't need to read that again. Our pictorial model contains all the information from that worded question, and I'll let you follow through the maths, and we're expecting to see some subtraction. Okay, question 2. Good starting point is always to ask, how many bars will I need here? Now, I'm expecting 1 bar because this is about Eva and her pairs. But let's see what happens. Let's see what happens here. So Eva has 6 bags of pears. Each bag has 4 pears. So these are equal parts because each bag has the same amount. And whenever we have equal parts, that's a big clue that we have a multiplication or division problem. And in this instance, this looks like a multiplication problem, because this tells us how many bags we have, how many pairs we have in total. Now, sometimes we end up with a before and after situation, and that's what we've got here. That so Eva has 6 bags of pears, then something happens. And so although I said it was 1 bar, we're actually going to end up drawing 2 bars. One is the before and one is the after. So this was the before, and we now have an after. And the one thing that we do know for our after bar is that it's the same length, and it's because it's still about 24 pairs. Okay. Eva gives her friend 9 pairs. How many pairs does she have left? And then we can see that being shown in our model. So let's just follow through the maths there. Okay, question 3. Again, I'm going to start off. How many bars do I need? Okay, well, I've got 2 numbers, A and B, so I'm expecting to see 2 bars. Let's see what happens. We don't know much about A, other than that it's 3 times as big as B. So we should have equal parts, 3 equal parts in A, 1 equal part in B. And equal parts should indicate to us that we have some multiplication or division or both to do here. We're told that the difference between A and B is 76. Now, the difference element is our double-headed arrow, and we can see that that difference element represents just 2 bars. So how many bars does that represent? 1, 2. So suddenly we're in a position to calculate what one of these is. And let's not forget what question we're asked. What is the sum of the 2 cards? Sum means adding up. So that's our curly bracket. Okay. So let's just follow through the maths here. And question 4. Again, we're going to check how many bars we need, first of all. And it looks like 3 because we've got 3 jars. Now, the second jar contains 3/5 of the number of counters in the first jar. Now, that suggests to me very strongly that we're working in fifths. So we're going to divide our first jar up into fifths, and we can see that our second jar represents 3 of those. Now, those are equal parts. We've got 8 equal parts here, so that should be really giving us a clue. Now, let's just have a look at what happens here, because this is about the third jar. And then what the third jar is doing is saying that the second jar is double the number of counters in the third jar, which means that the third jar, opposite of double, is going to be half what's in the third jar. All right. Now, that was going to be difficult because our third bar was not the same size, was not an equal part like those in our first and second bar. But what we've done, we found a common denominator and split it up. Instead of these parts, we divided each of those in half, and now 3 of these parts is the same as 6 of these parts. There are 90 more counters. Again, we've got a double-headed arrow because this is about difference, and we can see that that 90 represents 3 of these parts. So let's just have a look now at how the maths goes. And what were we asked to find? How many counters in the first jar? Okay. Okay, so that's the end of the video solutions for day 6 of Barvember. I hope those have been helpful. If you've got any questions, just go back to your maths teacher, but enjoy your bar modelling.